Okay, hello everybody. A little pressure to me by saying that I will present new innovations. There will be one, but hopefully that's enough for us today. Okay, basically I'm here to talk about energy efficiency in data centers. And to be precise, the energy efficiency in cooling. And as you can see, I have some comparing between crack and inline cooling. We'll go to that a little bit later. But reason why we are talking about cooling can be seen from this graph here. So, as you can see, 37% of all the energy consumption in data centers comes from cooling. Power distribution and backup is 10%, lighting, so on, it's only 3%. Somebody is saying, okay, we can save energy because we have LED lamps in our data centers, but of course you do that, but it's only a small part of that cooling or the energy consumption. And that's why the cooling is the crucial part from our point of view, because we are supplying data centers, and when people, Cisco people or somebody else came with their servers to the data centers, we have already gone. So we can't do nothing to the server consumptions, but what we can do is the cooling. We can start this presentation with a little short video. We can see some liquid cooling methods. The most common methods are using today. Thank you. So, when we're talking about cooling, we need to think about the whole network of the cooling. And it starts from here, from the chiller, and hopefully we are always using the free cooling. When we are talking about data center cooling, it seems like everybody is drawing a line here. We are thinking what happens here, but this is as crucial as this. And what happens in data center, it has affection here and vice versa. So if we start with room cooling, basic idea is to have crack units with double floor, and we use water to run out the hot air from the data centers. In worst case, this solution is open. So basically, we are running the cold air between the racks, driving the hot air back, but when the system is open, we have some problems, as you can see, because hot air and the cold air is mixing. And because of that, we have some lack of cooling power. The easiest way to have more benefit is to use cold air system, just covering up the corridor between these two cabinet rows. If we want to have more efficient cooling method, then we use page-suit cooling, or some might say in-row cooling, row cooling. So we will replace those crack units with liquid cooling units that are installed on the rack row between the racks. Basically, we can do all the same features as we had with cracks, but we don't need double floor, and the air is much more closer to the cabinets already. And we have, well, we'll go that on a bit later on, but we have the steady cooling air, cooling temperatures on the whole cabinet level. And the last one is the rack cooling, when we are talking about high density. Basically, the unit is the same, but in this case, we can even leave the other rack row totally. because we have more efficient system to use. We use so-called closed solution, where the cooled air is inside the cabinets. So the volume of the air is much smaller than it is for the when we're using cold air or hot air. And basically all the temperatures inside the room is handled other ways. So only thing we are affecting is the heat load of the rack, servers inside the rack. Joo.
Sieltä alhaalta 2 vasemmalle.
Tossa.
No joo, sitä. F5.
Okay, so if we go a little bit more detailed to these solutions, if we're talking about cracks, here you can see the so-called conventional way. We have the cooling coil and we have the fan, and everything is placed on the floor. One way to do it is to put this fan down on the below the floor, and the first affection is that with the same rack diameters we are able to get bigger coil, so then we are able to get more cooling power. And also, when the fan is below the floor, there will be no smaller pressure losses for the air. So, whatever crack version we are used, if we are talking about open solution, we will face some problems, as you can see from the picture here. Normally, the cracks are on one side of the room. And by that, we are facing our first problem, hotspots, as you can see from the temperature camera picture here. So these cabinets that are far away from the cooling device, they are okay. But as the warm air starts to move back on the crack, it will be mixed with the cooling air. And with these first cabinets, the products, the servers on the highest units will not have the same cooling power as these ones on the back. Because of that, the maximum heat load per rack is approximately 3 to 4 kilowatts per rack. As I mentioned, we are dealing with high pressure losses. We need this double floor. Well, usually it's not a problem because we do have some cabling and so on. So basically it's good to have double floor. But as I can say, there is also cabling which can affect the air. And that's why we are dealing with the pressure losses. And even if we are dealing with the clean environment, there are some possibilities, some impurities, for example dust, in the data center. The first step to improve the cooling is to use cold air. Just by covering up the corridor between cabinets, we can increase the heat load per cabinet from 3 to 4 to 4 to 6 kilowatts. And only because we can keep cold air and warm air separate. We still have pressure losses, as basic idea is still the same. We still need that double floor, and we still might facing the impurities in data center. But we already do have higher delta T values to increasing the cooling power. A little bit later I will go that what we can do with this higher delta T and what's the affection of that. But in this slide you can see that in figures the effect of cold ale. So open solution. If you want to have, for example, 17 degrees of Celsius, the cooling temperature in the highest unit of the cabinet, you basically need to blow 12 degrees Celsius of air to the data center. So the difference between first unit and the 42nd unit is 5 kelvins. Just by covering up the corridor, we are able to increase the temperature even more, because nowadays if we are using 13 degrees Celsius of air to cool down the servers, I think there's no need for that. It can be 23, 24 for example. This gives us opportunity to get higher delta T levels and higher return water temperature, and also we can set warmer water to the data center. We already checked on the video about this row-based cooling, which is basically the same as a rack cooling. But we don't need a double floor, and the cooling units are on the rack rows already. We can do the same modifications as we do with racks. Use the cold ale, or if we want more efficient system, we can also use the hot ale with the cold ale. Because now we don't have to deal with the warm air to get it back to the racks. All the movements are happening here. If we want even more energy efficient system, then we close the system. And here's the basic idea how it's worked. We still have the same cooling device running this cold air. I don't know what has happened to my arrows. They should be pointing to the servers, not out from the cabinet. But all the air is moving inside the cabinet. So still, as I mentioned, the air volume is much more smaller. And the benefits for the closed system. Now we can be sure that we are dealing with hermetic or clean environments. No dust or other impurities. The space requirements are much more smaller than the system would crack. We don't have pressure losses. We can control the air circulation, so we can rise up the temperature that we are blowing to the servers. The delta T, the temperature between the front of the rack and back of the rack, is much more higher, so we get more efficient cooling. And we have possibility to increase in cooling liquid temperature. It's the second time we are talking about increasing the liquid cooling, in cooling liquid temperature. And why that is so important? As on the video, there was chiller, and as I said, I hope that every time there is also a free cooling device. And why is that? We have two cases. First case, we are running data center with inlet water of 9 degrees. We are now talking about chiller with the compressor. So if you're using 9 degrees with the free cooling, we use compressors only 5 months during the year. So basically 7 months we are using only the cold outside air to cool down the water that we are using in data center. So the yearly cost is something about 11,000 euros. If we don't have free cooling at all, that cost might be something like 27,000. The data center size is 100 kilowatts. But if we increase the inlet temperature by 6 degrees to 15 degrees, we can still set 22 degrees to the servers as an air temperature. The compressor time reduces to 3 months per year. We have still 100 kilowatt cooling power. We don't change anything else but the water temperature that we are running inside the data center. And now we are dealing about the compressor time. We don't check about the pumps. So the yearly costs, if we do that increasement, is almost 5,000 euros. Only by hiring up the water temperature. And there is also some cases, some data centers that are using 7-degree water as an inlet. And if we are dealing that kind of data center, the inlet, the cost savings in 100 kilowatt data center is almost 6,000 euros. What about if we're talking about data center with 500 kilowatts, 1 megawatt? It might be a little bit different. So, there's some points of cooling and something that happens inside the data center and also outside the data center. But then, when we get back inside the data center, something we can do with the racks, it has nothing to do with water. It's only the installation of the racks, the cabinets inside the data center. As you can see, here's the so-called wrong way to do it. We have servers and other equipment, and all the empty units are open. So basically, the cold air that we will provide inside the data center to cool down the devices will go through here, because there's no pressure loss. Of course, in the servers you have some fans that will suck on in the air, but also air goes through here, so that will reduce our cooling power. This way here, this is closed system, but the same affection also in cold air system is that we should cover all these empty units. So basically then all the air that goes inside to the cold air, to this closed rack, can go through only the servers and nowhere else. It sounds quite a simple system, but unfortunately when we do some site surveys before new installations, we still found racks like this and even worse. Open environment with rack with 2 or 3 servers installed and nothing else. Then that innovation that was promised. This is basically made by Rittal Finland. We have a person named Marko Ruokonen who has defined this next product. We are calling it high efficiency cooler with heat recovery. And the idea is to cool down the water from the data center Here we have the inlet 7 to 17, hopefully closer to 17 than 7. And water we get out from the data center is approximately 25 degrees, 20 to 25. And here we have this heat recovery module with buffer tank. This is modified from ground cooling or thermal heating as is used for in houses. A little bit modified, and the result we get with this solution is, for example, the warm house water, maximum temperature is 70 degrees. Fair enough to the normal house. Or we can use it directly to the heating. But basically we are able to get the warm water with this to the other system to use in warming up. And as a modular device, we are able to increase the system with another module if necessary. So basically we can start with the smaller module, and when the data center increases, we can install a new one.
What is the power of single module? Power?
Depends. We have now one demo module, it's about 30 kV for the data center with the 30 kV, but it can be bigger if necessary.
And what's the power consumption?
Can you repeat the question?
The power consumption. I have to check that out from Marco. I'm not sure about that. Marco promised me that he's on the phone. I can check that thing from him. So please contact me on the break so you can check that out. But first, I can also give a fast answer to that. So basically, we are talking about COP of 5. So it also depends when we are talking about 30 kV of cooling, then we are dealing with 5 to 6 kV of power consumption.
So is that the same figure that's sometimes referred to as PUE, as power efficiency, power use efficiency?
No, this is basically comparing how many kilowatts we are using to cool down. Basically, a little bit same as an SPU, but like Finnish says that's something like that, but not at all. But yes, COP 5, compact structure, basically handmade by Rittal. And by that, as it's handmade and totally planned by us, we can assure that the components are used, they are reliable. We are able to integrate the energy monitoring. And as it was mentioned, we have 2 heating modes. We can provide warm water or heat distribution if necessary. And this can be connected to the existing water heating system. And also, if we do have existing cooling lines available, we can also connect this to that cooling line. But we can also use it as a standalone cooling device, so basically as a new installation to the brand new data center.
What is the size of the device?
The demo model we have is 180 centimeters wide to 200 centimeters high, 800 centimeters deep, something like that.
It's like a cabin size.
Like a cabin size, yeah. Basically same size as a crab.
Yeah. And that's enough to heat one single family house, for instance.
Basically, yeah.
Yeah,
I might say so, yes. At least providing that cool tap water we are using. Any other questions? Yeah.
heard some people trying to do liquid carbon dioxide cooling instead of water in order to get the cross-section of pipes down and so forth, and also to avoid spills from their leaks. Is this something you can talk about?
No. At this point, we are still dealing with water, and we are reliable that using water in data center is safe enough. But of course, we are looking for some new innovations, so probably in the future. But at this point, we are dealing with water. Any other questions? So if there's no questions at this point, I will be on our stand. So if you need further information, so please come up and have a chat. Thank you.